Welcome to our discussion on SQL joins. A SQL join is a powerful clause that allows us to combine records from two or more tables based on related columns. This capability is essential because it enables comprehensive data retrieval and enhances our ability to analyze information from multiple sources. Let us dive into the type of joins. First, we have the inner join. This join returns only the rows that have matching values in both tables. For example, in the query shown, we select employee names along with their department names by matching the department IDs. The results in a data set containing only employees who belong to departments. Next, we have the left join or left outer join. This join returns all rows from left table along with the matching rows from the right table. If there is no match in the right table, the result will include null values for those records. In the example provided, we retrieve all employees, even those without a matching department. Now, let us look at the right join or right outer join. This join returns all rows from the right table along with the matching rows from the left table. The result will include null values of those records. In the example provided, we retrieve all departments, even those without any associated employees. Finally, we have the full outer join. This join returns all rows from both tables, whether there is a match or not. For any non-matching rows from either table, null values will appear. The example shown retrieves all employees and all departments, showcasing the complete picture of both tables. Welcome to our discussion on DDL and DML languages in SQL. DDL stands for Data Definition Language, while DML refers to Data Manipulation Language. Together, these languages form the backbone of SQL, enabling us to define database structures and manipulate the data within them. Let us start with the Data Definition Language or DDL. DDL includes commands that define and manage database structures. Key commands include create, which is used to create new tables or databases as illustrated in the example. We also have alter, which modifies existing structures, and drop, which removes tables or databases entirely. It is important to note that DDL focuses on the schema and structure of the database rather than the actual data contained within it. Now, let us discuss the Data Manipulation Language or DML. DML include commands that allow us to manipulate and retrieve data. Key commands are insert, used to add new records to a table as shown in the example. Update modifies existing records and delete removes records from a table. DML is crucial for performing operations on the actual data in the database, making it an essential part of any data analyst toolkit. Welcome to our discussion on the difference between delete and truncate statements in SQL. Delete is a data manipulation language command that allows us to remove specific rows from a table based on a condition. In contrast, truncate is a data definition language command used to remove all rows from a table without logging each individual deletion. This fundamental difference determines how we choose to use these commands in various scenarios. Now, let us explore the key differences between delete and truncate. Delete is DML command allowing for selective removal of records based on specific conditions using the where clause. In contrast, truncate is a DDL command that cannot apply conditions and removes all rows. Additionally, delete logs each row deletion, which allow for rollback, whereas truncate uses minimal logging and cannot be rolled back. Delete can activate triggers associated with the table, while truncate will not. Finally, truncate is generally faster for large datasets due to its efficient handling of data removal. Here are examples of both commands. The delete statement is shown removes employees from a specific department, while the truncate statement quickly clears all data from the employees table. In summary, use delete when you need to target specific rows and opt for truncate when you want to efficiently clear all data from a table. Understanding these distinctions is essential for effective database management. Welcome to our discussion on the case statement in SQL. The case statement is a powerful conditional expression that allows us to incorporate if then else logic directly within our SQL queries. Its primary purpose is to enable dynamic data presentation based on specific conditions, making it particularly useful for categorizing data, performing conditional aggregations, and generating dynamic result sets. Let us look at the syntax of the case statement. The basic structure includes the keyword case followed by a series of conditions. For each condition, we specify a result to return if that condition is met. We can also include an else clause to define a default result if none of the conditions match. In the example shown, we categorize employees' salaries into low, medium, and high based on the specified salary ranges. Here is a practical use case of the case statement for categorizing employee salaries. In this SQL query, we select the employee's name and salary, and we use the case statement to determine the salary category. The result will show each employee's salary alongside their corresponding category, allowing for easy interpretation and analysis of salary distributions within the organization. This demonstrates how the case statement enhances the readability and functionality of our SQL queries. Welcome to our discussion on the differences between distinct and group by in SQL. Distinct is a keyword used to return unique values from a column, while group by is a clause used to arrange identical data into groups, often in conjunction with the aggregate functions. Understanding these concepts is essential for effective data retrieval and analysis. Let us explore the key difference between distinct and group by. Distinct is used to remove duplicate values from the result set, ensuring that only unique rows are displayed. In contrast, group by is used to group rows that share a common property, often resulting in summary statistics. Distinct does not perform any aggregation, while group by is typically used with aggregate functions like count, sum, or average. The result set for distinct includes unique rows, whereas group by returns one row for each group based on the specified columns. Here are examples of both distinct and group by. The distinct example retrieves unique department IDs from the employees table, ensuring that each ID appears only once. On the other hand, the group by example counts the number of employees in each department by grouping the results based on department IDs. In summary, use distinct when you want to filter unique records and use group by when you want to summarize data based on groups. Both are powerful tools for data manipulation in SQL. Welcome to our discussion on the union operator in SQL. The union operator is used to combine the result sets of two or more select statements, enabling us to retrieve unique records from multiple tables or queries. Understanding the rules for using union is essential for effective data manipulation. Let us go over the key rules for using the union operator. First, all select statements involved must have the same number of columns. Next, the corresponding columns in each select statement must have compatible data types. Additionally, the column names in the final result set will be taken from the first select statement. It is important to note that union removes duplicate records by default. If you want to include duplicates, you should use union all. Lastly, the order by clause can only be applied to the final result set, not to individual select statements. Here is an example of how to use the union operator. In this query, we select names from the employees table where the department ID is 1 and combine it with names from the contractors table in the same department. This allows us to retrieve a unique list of names from both sources, demonstrating how union can be effectively used to consolidate data from different tables. Welcome to our discussion on the difference between drop and truncate in SQL. Drop is a command used to completely remove a table or database object, including its structure and data. On the other hand, truncate is used to delete all rows from a table while keeping the table structure intact. Understanding these differences is crucial for effective database management. Let us explore the key differences between drop and truncate. Drop deletes the entire table structure, including data and metadata, while truncate only removes the rows and retains the table structure. Drop is slower due to metadata cleanup, whereas truncate is faster because it involves minimal logging. Drop is used when a table is no longer needed, while truncate is ideal for resetting a table. Both operations are DDL commands and cannot be rolled back. Here is an example to illustrate the difference. Using the drop command, we can delete the entire employees table, including its structure and data. In contrast, the truncate command removes all rows from the employees table but keep the table structure intact. This makes truncate a useful tool for quickly clearing data without losing the table definition. Welcome to this presentation on how to find the lowest salary of employees in each department using SQL. In this session, we will explore an SQL query to extract this information efficiently. In many organizations, salary analysis is crucial part of HR and financial management. Our goal here is to determine the lowest salary in each department from an employee database. This can help in decision making related to salary structuring. The SQL query shown here selects the department ID and finds the minimum salary in each department using the min function. The group by clause ensures that the results are grouped by department. To make the results more readable, we can join the employees table with the departments table using the department ID. This way, we can show the actual department name instead of just an ID. Here is an example data set of employees with their salaries and department IDs. After running our SQL query, we get the lowest salary for each department. Welcome to this session on how to fetch unique values in SQL using the distinct keyword. In this presentation, we will explore its syntax, usage, and real-world applications. The distinct keyword in SQL allows us to fetch unique values from a column by eliminating duplicates. It is useful when we need to find distinct categories, departments, or any other non-repeating data. The syntax of distinct is straightforward. We simply add the distinct keyword before the column name in the select statement. This ensures that the results contain only unique values from that column. Let us consider an employees table where each employee belongs to a department. Notice that some department names are repeated. By using select distinct department from employees, we remove duplicates and get a list of unique departments. The output contains only 3 department names: HR, IT, and finance. Distinct can also be used with multiple columns. This ensures that we get a unique department and job title combinations instead of just unique departments. Distinct is commonly used in business scenarios such as finding unique product categories, listing distinct customer locations, or analyzing sales trends by unique transaction dates. While distinct is powerful, it has some limitations. It may slow down queries on large data sets and it only works at the column level. For more advanced filtering, group by is a better choice. In summary, distinct is a useful SQL feature for retrieving unique values. It helps in eliminating duplicates and is frequently used in reporting and analytics. This concludes our session on distinct in SQL. Welcome to this session on the Datediff function in SQL. In this presentation, we will explore how Datediff helps in calculating the difference between two dates, its syntax, use cases, and practical examples. The Datediff function in SQL is used to calculate the difference between two dates. It is useful in various applications such as calculating employee tenure, project durations, or age from a birth date. The syntax of Datediff function requires 3 parameters. The first is the interval which defines the unit of difference like days, months, or years. The second and third parameters are the start date and end date. In this example, we calculate a person's age using the Datediff function. The interval is set to year, the start date is the birth date, and the end date is the current date using getDate. The output returns the person's age. In this example, we calculate the number of days between January 1, 2024 and March 11, 2024. The result is 70 days. The Datediff function is widely used in various industries. For example, HR departments use it to calculate employee tenure, finance teams track subscription expiration, and healthcare applications calculate patient age. While Datediff is a useful function, it has some limitations. It only returns whole numbers, meaning it rounds differences. It also ignores time differences, focusing only on full days, months, or years. To summarize, Datediff is an essential function for calculating date differences in SQL. It supports different intervals, making it useful in a variety of real-world applications. This concludes our discussion on the Datediff function in SQL. Thank you for watching. I tried my best to explain the 10 different topics one by one. Subscribe and click the bell button for notifications of the next parts of this video series.